Dear students, I welcome you all for the online learning platform. We are learning the course through online platform. So in unit 2, actually we are learning through online. So the sequence was like this: unit 1 we have finished first, then unit 3, and now we are discussing unit 2, and already 4 chapters we have finished, and today's chapter will discuss about an interesting part of identification of bottlenecks and congestion points. See, what is a bottleneck in the context of warehouse? Of course, from the through the application of queuing theory, we are going to learn, and the congestion points. What all are the congestion points are there? So these all are the things what we are going to learn in this regard. Okay. So before we get into the part, we need to understand there is a problem in a warehouse. So the moment we understand the problem, we are applying queuing theory into it, and we are trying to solve the problem by means of application of this numerical methodology. So in the due course, what we learned here is one important aspect, that yes, the problem has been numerically identified and how to solve it. So that is what is bottleneck and congestion points, and that's where the next we take it to the service level management and proactive identification and mitigation. So 7, 6 and 7 are nothing but the queuing models. Already we have solved problems in this regard. So all these things are chain linked. Okay, let me put it again. See, we have got a queue. We understand there is a problem in the queue. How to solve that particular problem? Mathematically, we are just identifying, and upon identification, we just come out with some measures how to solve, how to resolve. That is what service level management. And next, how to forecast this and how to mitigate the entire process. So this is what we are going to learn in the even in the subsequent sections. So now we'll get into the bottleneck. So identifying bottleneck and congestion point is very crucial when you wanted to optimize the warehouse automation system. Okay, you got a system that has been automated, but still the performance is not to the expectation. Means some sort of fine tuning is necessary. Some fine tuning of the entire process is essential, so that we gain, or we absolutely we rejoice the output of the entire process. So we should know that particular part. So that is number one. So despite all these things, still we are unable to make the outstanding mark. Means the fine tuning of the system is essential, and that is where we thoroughly analyze the bottlenecks and congestions, how the bottlenecks creates, or what all are the reasons for such things, and how to troubleshoot all such things we'll be learning in this particular act. First, bottleneck: a point in the process where the flow of goods slows down, reducing overall throughput. So we have got a series of system. So we have received the order, we have packed everything, so nicely packed, all the KPIs have been obeyed. Now it has been sent to elsewhere for shipping. Because of some reason, somewhere it is getting stuck, and do you think further flow will be there? Obviously no. Why? Because something has been struck in between. So because of this struck, what happens is the entire process is going to slow down, and output will not be as expected. Such situation is called as bottleneck. Okay. The next is congestion point: physical or operational areas where multiple processes or system overlap, causing delays and conflict. Okay. Congestion point. So to understand simply, orders have been picked. So now hundreds, say, let me put simple, some 5 orders are waiting. Now packing is taking good amount of time for the want of some packing materials, or because of lack of labor, something like that. And now this is congestion point. So bottleneck means the entire flow will be disrupted. Congestion point means everything is okay, because of one small activity the entire process couldn't be culminated, you can't complete it comprehensively. So that is called as congestion point. So we should have a thorough understanding between bottleneck versus congestion point. Both the things are negative, but bottleneck will completely affect the entire system, where congestion point will affect a part of the process, and that might lead to the delay, or that might lead to even a bottleneck later on. Now we shall classify the bottlenecks like this. So first bottleneck is infrastructure bottleneck. So when you subclassify it, first is chronic and temporary. First we will see the classification, then we will see their application. Then next is regulatory bottlenecks, direct, indirect. Operational bottlenecks, capacity, efficiency. So these all are the three bottleneck types. So now we'll see one by one. So chronic type infrastructure bottleneck means climate will influence. Climate, under investment, physical restrictions. So these all are the things comes under chronic type of infrastructure bottlenecks. The next is temporary. Weather, construction and accidents, demand surge, disinvestments or with respect to infrastructural type, temporary type of bottleneck. Then regulatory bottleneck is direct because of the regulations by the government, customs or some security or compliance to some sort of quality or safety standards might be the reason. Indirect means cabotage, competition policy and fiscal policy with respect to finance. Everything comes under with respect to the finance. Operational bottlenecks, capacity, what is the maximum parts that particular system can handle, but still you wanted to do something extra means yes, it is going to work beyond its capacity, so we can expect. Or shortage in labors. Efficiency, productivity modes and terminals, labor skills and coordination. So it starts right from physical requirement till the skill level of the operator. So across all this bandwidth, we are going to identify the bottlenecks. Now, simple examples, let us see one by one. First, inbound receiving. So inbound receiving means we receive the orders, that is we receive the products even for the case of storage. So first, what might be the initial bottleneck? Delays in unloading and checking incoming goods. Somebody should come, some inspection guy should come, he should inspect and he should verify, yes, the product is of quality. Then that has to be unloaded. If that itself is taking good amount of time, so that is going to be a bottleneck. So what might be the cause? Limited dock doors, only one opening might be there, you can't accommodate more than one truck, so that will be the reason. Slow scanners, some sort of checking, some hardware requirement, uncoordinated schedules. So we should have a proper coordination, who will take care, when he will take care, what all are the works he is going to do, likewise we should know. So the impact is inventory not available for picking. See, now the part has come to the warehouse, it is in the truck but not inside the warehouse, but still what the WMS will show, it will show that no, there is no part available, but actually we are having. So that leads to loss of business. So customer will go for the next case, next alternation. So that will lose completely, that will spoil their repute. Okay. Put away systems, slow allocation of storage locations, inefficient WMS logic, robotic traffic jams, full racks. See, you have got everything. Now only 10 parts can be accommodated, but you have got 11 parts. Where do you keep that 11th part? 10 racks, the part is full, the rack is full. Where do you keep the next one? So that is what the cause is all about. So the impact is storage areas backlogged. So that we will keep somewhere like that. So your proper arrangements will be spoiled. Then ASRS. So we knew this is going to be the best concept. Slower expected item retrieval, mechanical limitations, high item density, poor slotting. Okay, we need to have a proper location for all these things. Once if there is inefficiency in this regard, so obviously we cannot expect the systems to be performing good. So ultimate impact is we will not be able to fulfill the orders. Conveyor lines, overflow or blockage in the conveyor belts. See, conveyor belts means they have got their own efficiency, only these many parts per minute or hour. So that has to be carefully respected. If that is not being followed, obviously we cannot expect that to perform well. So that has to be strictly obeyed. So imbalance to flow, packaging delays, sensor errors. So finally what will happen? The system might become halt or some rerouting has to be done. So packing stations. Orders pile up waiting to be packed. We discussed in the earlier slides. Orders will be ready, but there will not be sufficient infrastructure to pack it up. So fewer stations than required, manual intervention errors. So shipment delay. Everything is ready, but it has not been packed. Can we move for further shipment means no. So that will lead to the further delay. So shipping dock areas, queues at dock doors or shipping buffer. So what might be the potential cause? Insufficient staging, truck delays or poor scheduling. So finally delayed dispatch. Everything will be ready. This truck should move away, then only other truck can come so that we can give away the packed products. So this might be the reasons. So physical congestion, so typically they occur aisles shared by multiple robots or pickers. See, you got an aisle, only one robot can go in between. Now you want two robots to go in between, means no, one should go, it should complete the process and then it should come. So till then this robot will be waiting outside. So that is one congestion point. Cross docking zones where inbound and outbound processes overlap. See, if the layout is improper, there will be only one entrance and one exit. So only one truck will be waiting. That truck area will be used for inflow as well as outflow. So for the want of any one process, the other process will idle. So that is the second case. Third, charging stations of say forklifts or AMRs. See, only one charging point is there, so we need to wait till the point is getting vacant. So again congestion will come into picture. Packing and labeling areas with insufficient space. See why? Because this is another area. Labels might be wrongly pasted onto the other product. First label should be on the first product. Suppose if you change it to some other product, entire things gets mismatched. So we should have sufficient space. Buffer zones with limited capacity. For anything we should have a buffer zone, some cushioning effect should be there. So these all are the reasons why congestion points physically occur. Now what all are the tool? So first WMS, properly we should use a WMS, then WCS, warehouse control system, then digital twin. We can forecast by means of sitting in a computer, we can physically we can know what sort of things will happen by means of a digital system. Then heat maps, so usually for sensor oriented cases we can go ahead with this. Time motion study or CCTV or drone monitoring to identify where the exact congestion occurs, what's the reason for congestion we can analyze, and on systems. So these all are reason to develop systems where we can simulate everything and we can sit in the place and we can solve the issues. So these all are the tools what we can use it. Now for the both these cases, you have got all these things, but still we should have KPIs for them. So the KPIs are track item flow. See, we know the fact that KPIs should be tangible, that should be quantifiable. It should not be based on assumptions or something qualitative basis. So for each and everything we should have a measure against which it can be rated. Now, what all are the basic reasons for any congestion is the first foremost thing to be blamed is design and layout. So proper design, a proper layout. So in the layout category we learned inbound and outbound should be adjacent, but they are not supposed to be same. So that has to be taken care. Technology optimization. We use technology, but that may not be appreciably good at initial cases. We should fine tune them and we should ensure that they are doing good. Then the other important thing is real-time monitoring. So 100% dynamic monitoring is essential so that we can identify the bottlenecks then and there. Then scheduling. Plan properly. Only one exit and one entrance is there, means plan properly. From this time to this time, a roster can be given. Only that particular inbound activity should occur. Then during this duration, outbound should occur. So likewise, we can schedule properly. So we come to the end of the presentation. So to summarize, so we discussed about bottlenecks and congestion points. What is bottleneck and what is a congestion point? The basic definition we understood, followed by the tools, the KPIs for those tools we discussed, and finally the reasons, the factors why such bottlenecks and congestion points occur, we just understood by means of the layout, scheduling and other related parameters. So with this we finish this presentation. So students, please note down any doubts you have got. So during the offline classes or during online discussions we can clarify the same. So thank you.